All right, the question I'm trying to answer is which reactant is limiting and which is excess if I have 50 grams of my Mg2Si and 50 grams of water in a double displacement reaction. So the first step we need to do is we need to balance our equation. The equation's unbalanced right now. And so for me, I like to start with, I usually leave water for last, or any simple ones. So I see I have 2 mg's over here, but only 1 mg over here. So I'm gonna go ahead and double that and see if that helps. So now I've got 2 mg's, 2 mg's. Now I have 1 SI, 1 SI, those are good. So let's look at my water here. I have 2 H's on this side, but I have 2 times 2 here, so 4 H's plus another 4 H's. So I have 8 H's on this side. So if I add a 4, I've got 8 H's between both my products here. And I have 4 O's, and so then I have 2 times this O, but take it times 2 here also. So I have 4 O's, so my equation is balanced. So the first thing I'll do is I'll start with either of my reactants. So remember, reactants are on the left side of the arrow, and then our products are on the right. So I choose one of my reactants to start with. So I'll go ahead and start with my Mg2Si here. I've got 50 grams. So I start out with writing my grams of one reactant. And I'm gonna change that from grams to moles. So to change from grams to moles, I have to use my molar mass. I Googled what my molar mass was, and I found that 1 mole of Mg2Si is equal to about 76.70 grams. So you can Google that, or you can look up on a periodic table the mass for each of those elements. But for me, the Google is a little easier. So I'm starting with 50 grams. To go from grams to mole, I use my molar mass here. So that means that 76.70 grams is equal to 1 mole. This is all Mg2Si. And then, so I've got grams Mg2Si, grams Mg2Si diagonally. So now I go moles. I'm gonna go from moles Mg2Si to moles of my product here, MgOH2. So to go from moles to moles, I use my coefficients, my stoichiometric coefficients. So since there's no number out in here, that's the same as a 1. So that means for every 1 mole of Mg2Si I have here equals 2 moles of MgOH2 of my product. So I'm gonna go ahead and write that next on my block. 1 mole Mg2Si is equal to 2 moles of 2 moles of MgOH2. So now I'm kind of done here, so I would multiply my numbers across. So I would take 50 times 1 times 2, which equals 100. I'll divide that by 76.7 times 1. And I already did that on the calculator, and I came up with, this would create, if I had 50 grams of Mg2Si, that would equal 1.30 moles of my product, which is MgOH2. Then I'll do the same thing with my other, so I did one reactant up here. I'll do the same thing with my other reactant. I already have that drawn out over here. So I took my 50 grams of H2O, its molar mass, so it has 18.02 grams per 1 mole. So I use the molar mass here. Then I go from moles of H2O to moles of my same product. So how I went from moles of Mg2Si to moles of MgOH2, I do the same thing with my water. I go from moles of H2O to moles of my MgOH2. And in my balanced equation, I see that for every 4 moles of water, I have 2 moles of this product. So I go 4 moles H2O equals 2 moles MgOH2. Now I will multiply out. So I take 50 times 2 times 1 is 100, and I divide that by 18.02 times 4, which equals 1.39 moles. So my Mg2Si, when I had 50 grams of that, that will produce 1.3 moles of my product, where 50 grams of water will produce 1.39 moles of product, of my product here. So the smaller number is my limiting, which means the bigger number is my excess. So limiting and excess.